All right, this is section 9.4, performing rotations. First thing I have to do is I have to define what a rotation is, and basically what a rotation is, it's a transformation in which a figure is turned about a fixed point. Since it's a transformation, that means it preserves the isometry, which means that the shape of the figure does not change, the size of the figure does not change, it just changes position. The center of rotation, that's going to be an actual fixed point that I will give you either in directions on how to do these, but the fixed point is always going to be what the figure is going to be rotated about. The angle of rotation, that's going to be what you're going to be basically constructing with either your protractor or is given to you in directions, but it's formed by rays or from rays drawn from the center of rotation to a point and its image. And this is much more evident when you actually have to rotate a figure, which is in the other video of rotating a figure. Okay, so we have coordinate rules for rotations about the origin. This is in an XY axis. And basically the great thing about this is it's 3 rules. You just follow the 3 rules. So I'm going to take my practice point to -3. So if I wanted to rotate this point, and again it's about the origin, so that's the point 0, 0 on an XY axis. For a rotation of 90 degrees, the point AB becomes, you switch the A and the B's position, then you take the opposite of B. So in this case, I'll switch the -3 and the +2, and then I take the opposite of this value, which would be a +3. And that's my point rotated. So all you're doing is just applying the rules. That's it. So for a rotation of 180 degrees, this one's the easiest. You just take the opposite of both of them. So this would be -2, comma, opposite of -3 is +3. And that's your point that's rotated. And last but certainly not least, rotation of 270 degrees. You switch the 2 points and then you take the opposite of the A value, or the second value. So I'm going to switch the 2 points. So we got -3, comma, 2. And then I take the opposite of the second value, which would be opposite of +2, which would be -2. And that's it. So if you're faced with a quadrilateral, you just do it 4 times. Triangle, you do it 3 times. Okay, so we have graph the quadrilateral RSTU with vertices R is 3, 1, S is 5, 1, T is 5, -3, and U is 2, -1. Then rotate the quadrilateral 270 degrees about the origin. So this is just applying the rules. So all you're going to do, you look back 270 degrees about the origin is this one right here. You're going to switch it and take the opposite of the second one. So let's switch it. So R prime would be 1, -3. Okay, switch it and take the opposite of the -1, or the opposite of the second one. And then 1, -5 for S prime. And so on and so forth. It's a pretty simple concept. So all you do, when you graph it, that's your graph right there. So all the actual values, 1, -3, 1, -5, -3, -5, -1, -2. So switch it, take the opposite of the second one. And if you notice, there is the 270 degree rotation that you can actually see. It goes from R, S, T, U to R prime, S prime, T prime, U prime. And make sure you have the proper notation with this. And you also, in terms of prime notation, and you also plot the correct points. Okay, what about this figure here? It says graph triangle JKL with vertices J is 3, 0, K is 4, 3, and L is 6, 0. Rotate the triangle 90 degrees about the origin. So looking at the rule, what did 90 degrees about the origin do? You have AB becomes, you switch it and take the opposite of the first one. So let's switch it and take the opposite of the first one for each one of them. And this is what you should come up with. Your J, which was 3, 0, should now become 0, 3, because there's no opposite of 0. Your K, which is 1, 2, 3, 4, up 3, now becomes -3, up 4. So on and so forth. This is what it should be, and this is the rotated figure, 90 degrees about the origin. Okay, and the last one, Quadrilateral is rotated about point P. What is the value of y? So what you have to do is you have to kind of visualize and see, okay, what parts, corresponding parts, when it's rotated are the same. So like, what is 5y's corresponding part? Well, would it be 8, or would it be 3x plus 1, or 6? Well, if you rotate it, kind of look and see what it does, you can see that it comes to the 3x plus 1. Because if you notice, this line here means that this line here would be the 8 in terms of equivalence. So that guy would be 8 if you want to think of it like that. So the 5y is equal to the 3x plus 1. The 2x is going to be equal to the 6. So 2x is going to be equal to 6. So we have two equations and two unknowns. And in order to find the value of y, we have to actually solve both of them. So solution is, so once we do this, substitute x in for 3 because you divide by 2. And once you do that, you just solve and get 10 divided by 5, which gives you 2. And you're done. So it doesn't get much more complicated than that. The main theme on this whole chapter is think simple. If you're having trouble with it, chances are you're probably overthinking it. And remember this word, isometry, because that's going to be important throughout.